Okay, applications also create threats for us. First of all, configuration. Many times we install software and we just take the defaults. In fact, I always laugh when people install a piece of software and they go next, 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 next. And all of a sudden they're shocked and surprised that they have a new toolbar. That's a bad example, but you know what I'm trying to get across here is that sometimes we install software and without configuring it properly, we could actually expose ourselves to additional threats. Another great example of this would be, oh, let's say you go down to your local technical store and you pick up your new Linksys router and you bring it home and you follow the instructions. It says plug it in, turn it on, push a magic button, and hey, does it work? Yeah, it works great. Yeah, so how secure is it? What's the password? Well, I'll tell you what the default password. Let's see, on a Linksys router, it's either admin as a username and admin as the password, or it's admin as the username, or blank password, or it's admin as the username and password as the password. You don't want to set up something and take default configurations. Also, we have buffer overflow issues. Now, with this screenshot, you're probably thinking, Dale, that's a blue screen of death. And you're right, it is. It could be caused by a buffer overflow. A buffer overflow occurs when you have a process or a program that's trying to store more data in the buffer than what it was intended to hold. And in which case, it overflows into the next area of the buffer. Now, sometimes this can actually happen accidentally through programming errors. Buffer overflow, however, is becoming increasingly common in the types of attacks that we see on data integrity. In fact, back in 2000, there was a famous buffer overflow that affected both Microsoft Outlook and Outlook Express. And what happened is that there was a flaw in the programming that made it possible so that a hacker could compromise a system just by simply sending an email to the target. They didn't have to open the email. They didn't have to read the email. They didn't have to forward the email. Because the program's message header mechanism had a defect, it made it possible for the senders to overflow the area of data, and then it allowed the attacker to execute whatever code they wanted to on the client's machine. Now, this whole process took place as soon as the recipient hooked into their mail server. And so it was very, very hard to go through and defend and fix. Microsoft finally had to release a patch for it to stop it from happening. We also have lazy coding. Lazy coding, now I don't want to offend any developers here, so I'm not going to group you all together, but there are some programmers that are lazy and they copy and paste code between applications or shared code. We actually end up dealing with something called a shrink wrap attack, which we'll talk about a little bit later on. Any type of coding that's utilized in in-house development should be reviewed. If you purchase customized software for your industry, somebody should be reviewing that information to find out what's there. Because the last thing you want to do is install an application that's going to create a whole new threat for you. And lastly, we've got data and input validation. So what this does is this is typically focused in on web-based applications. Web-based, and the most notorious of this is what they refer to as SQL injection, but it happens everywhere. Developers go through, we create these web applications, they run beautifully. When we have these fields that people fill out information, it expects certain fields. Sometimes they don't even differentiate what type of information is supposed to be in there, whether it's alphanumeric or it's digits or what. And based off of that, if I don't validate the input or the data that gets thrown into these fields, an attacker can actually cause the software to have basically a hiccup and then allow me in through a vulnerability. And again, like I said, this is what SQL injection did to us, is it allowed the attacker to hit your external website, maybe as a website for ordering product, and if he could figure out that you were using an SQL service, actually he didn't even have to figure it out. He could issue a couple commands and find out if it responded. And if it responded like an SQL server that hadn't been patched, from the first name field, if that was the name of the first field that was there, he could actually go in and do things like select object and go through and select a database and create an account. It's really, really quite scary. So anytime you deal with applications, you need to make sure that folks are doing data and input validation.